Let's take a look again at the subnet masking, which would be PowerPoint 22, and let's take a look how they're coming up with these values here. The last address consists of 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This is the 2 to the 0 power, which is 1. This is the 2 to the 2, or 2 to the 1 power. This is 2 to the 2 squared, 2 to the 3rd, which is 8. 2 to the 4th, 2 to the 5th, 64, and a 128. So if we put a 1 in the 128 location, that's where we get the 128 from. So now with that 1 there, this is how that last 8 bits will look. It's going to have 7 zeros. 1, 2, 3, 4, 6, 7. Okay, so this right here, you're kind of like looking at it backwards now. This is going to be 2 to the 1st power, which is a possible of 2 subnets on the network. The hosts are going to be what's left, and what's left is 1, 2, 3, 4, 5, 6, 7 zeros. So this calculation comes from taking 2 to the 7th minus 2, which gives us 126. All right, let's take a look at the next one. The next one, what we're going to do is we're going to put a 1 right in this location. So let's label this. This is A, B, C, D. This one is A. Let's look at B. B is going to be 1, 1, and then I'm going to have 6 zeros. 1, 2, 3, 4, 5, 6. So this combination here is 2 to the 2nd, which gives me 4 possible subnets. And what I have left are 6 zeros, so this is 2 to the 6th minus 2, which is 64. So take away 2 is 62. That's how we get that calculation. Now let's move over to the third one here, which is C. Not class C, this is just letter C. So now I have, I'm going to put another 1 right here. So I have 3 ones now. 1, 2, 3, and the rest are zeros. 1, 2, 3, 4, 5 zeros. So here the possible subnets is 2 to the 3rd, which gives me my 8. And what's left is 1, 2, 3, 4, 5 is 2 to the 5th minus 2, which is 30. And that takes care of that 30. Now the 128, the 192, the 224 numbers, that's coming directly from here. If you only have a 1 in this location and you look at this as an entire binary number, a 1 in that location would be 128. If you have 2 1s, it's going to be 128 plus 64, 128 plus 64, that gives me my 192, and then over here I have 128 plus 64 plus 32, that gives me my 224, and then you can carry through with the other ones in the same process. This next chart just lists the equivalent numbers. 128, two ones here, you take 128 plus 64 to get the 192. The 3 ones here is, again, 128, 64 plus 32 gives the 224, and so forth and so on. On this example, we just received our Class C address right here, and our subnet mask of 255, 255, 255, 224. So looking back at the previous slide with the 224, it tells us we can have 8 subnets on the network and up to 30 hosts per subnet mask. So now we want to determine the calculations here for the identifiers. Okay, so it says write the last masking octet as a binary number. So that's going to be the 8 zeros at the end that we just looked at before. Okay, and it says determine the binary place of the last masking digit. Okay, so the last masking digit, since this is the 224, let me get back to this other slide. since it's the 224 network, that's right down here, this right here is the last digit, the third one over. So basically what I have left are 1, 2, 3, 5 zeros. So let me return back to the previous slide and enter that in. If I can find. Now we're going to learn how to divide it all up. So it says determine the subnet identifiers by writing, it says write the last masking octet as a binary number. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. And from our example, we had 3 ones in that first location with 5 zeros. 1, 2, 3, 4, 5. So the last digit or the last bit of the masking determines this increment, this 32. So this is 2 to the 0, 1, 2, 3, 4, 5. It's 2 to the 5th power, and 2 to the 5th power is my 32. So now what I have to do is get all of my ranges. That's where all these calculations are coming from. We're going to start over here where we have the mask is the 3 ones. Notice that there's 3 ones in every single location. And the decimal number 0 is 0, 0, 0. Everything is 0. Then when we get to the increment, because we're incrementing by 32, we're going to put a 1 here because this 1 in this location is 32. So 1, 0, 0, 0, 0, 0, that's 32. Then we go to 64. 64 is 1 in this location. 96. 96 is, again, the next increment of 32. So to get to 96, you need to add 64 plus 32. And 128 is a 1. 160 is 128 plus 32. And 192 is 128 plus 64. And this one here is 128 plus 64 plus 32, and the rest are zeros. But the reason they're making this box is notice these 3 bits here. These are basically counting in 3 bits all the way up to 7. So 0, 0, 0, then you got 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, 1, 1, 1 is 7. And that is going to give us our differentials for the subnets. Alright, so the 2 to the y is the number of usable subnets. So those come from the first 3 digits, or the first 3 bits on that previous example, which is this comes from the previous example, which is here, calculating how many subnets on the network. So it depends upon how many digits or how many bits you're taking away from the first 3 locations. So that is going to be the 2 to the y, which is right here. So 2 to the y, that's going to give us the number of subnets. And 2 to the x minus 2, that's the number of usable hosts that is allowed. And here they're just showing that example again, where on this particular one they're taking 4 away from the last 4 bits. So the number of subnets is going to be 2 to the 4th, which is 16. And there's 4 zeros left, so that's going to give us the host, which is 14 usable hosts. So if we had to take a range from our previous example, which is, let me get that IP address again, 199.1.1.0.0. All right, 199.1.1.0.0. So 199.1.1.0.0. All right, and we just figured out that the increments are 32. So what we're going to do is our subnets are going to be 199.1.1.0.0. That's the first one. Then we have 199.1.1.0.32. 199.1.1.0.64. And you keep going. 1.1.0. So 64 and 32 is 96. And then the next one is 199.1.1.0. So 96 plus 32 is 128. And I keep going all the way until I get to the end, which was the last one they said to use, which was 224. Okay, so I'm going to go all the way to the end, all the way up to 224. Alright, so then if I'm looking at the actual lab and I'm trying to apply this example to the lab, that one would be step 8. So step 8, that's what you're going to list. But for step 8, you're only going to have a total of 4 subnets. Alright, then for step 9, it says use the last address on any subnet, or the last address on any subnet is always the broadcast address. Find this possible IP address for each subnet. So if the first one, broadcast, let's just put here broadcast for the first one. So if the first one goes from 0 to 30, here it is, 0 to 32, the broadcast address for the first one is going to be 110.31. The broadcast address for the second one would be 199.1.1.0, and that's going to be 63. Then the next one goes up to 96, so it's 199.1.1.0.95. So that's how you want to do step 9. Then step 10 says use the remaining addresses for the hosts. What is the range of hosts on each subnet? So what we're going to do is we're not going to use, it said not to use the first one or the broadcast address. So for this is question 9. For question 10, this is question 8. What we're going to do now is, since my first one goes from 0 to 31, I don't want to use those. So the range for that is going to be 199.1.1.0.1 all the way to 199.1.1.0.30. So that's going to give me the range. And that would be for the first one. The second one, it's going to start at 32, but I don't use 32. So the second one's going to go 199.1.1.0.33 all the way. Now I can't use 63, so it's all the way to 199.1.1.0.62. And I keep doing that for those addresses. For question 11, it says assign the first host IP address in each subnet address to a router interface. So for question 11, what I'm going to do, again, according to this example, I'm just going to pick the first one that I assigned. So it's going to be 199.1.1.0. Let me write that down. 199.1.1.0. And then the first one will be my point 1. The second one is going to be 199.1.1.0. And then it's going to be 33 because that's the first one. And then the next one, 1.1.0. After 33 was 64, so it's going to be 65, etc. And I can just keep writing those out. For step 12, it says, write the last octet of the subnet address in binary. How many bits are in the host portion what does the host portion of these addresses look like? All right, so for question 12, again, I'm doing it according to this example, a 0, so all I'm doing is I'm rewriting my bits. So for the first one, I have 4, 5, 6, 7, 8. I have 8 zeros. That's for 0. And then I have a 32 is next. And my 32 is going to be 0, 0, 1, 1, 2, 3, 1, 2, 3, 4, 5, 5 zeros. Then I have a 64, which is 0, 1, 0, 1, 2, 3, 4, 5, 64. And then I have 96, so it's 0, 1, 1, 1, 2, 3, 4, 5. And again, I'm basically looking at these 3 digits here, and I am counting up until I get to 7, and that's going to give me my ranges. So if I had 2, I would be counting 0, 0, 0, 1, 1, 0, 1, 1. All right, so that's question 12, and again, keep going until you get to the end. Question 13 says, oh, I didn't finish this one. It says, how many bits are in the host position? The host position in this particular example is going to be the 5. So there's 5 bits in the host position. So if you're only using 2 bits on the left, then you're going to have 6 in the host position. And in this case, it's asking what they are, and they're all zeros. All zeros. Okay, question 13. Write the last octet of the broadcast address in binary. What does the host portion of these addresses look like? All right, so the last broadcast address, for the first one anyone, was 31. So then I have to write that in terms of binary. So a binary 31 is going to be made the following way. The easiest way to do this is to realize that a 32 is 1, 0, 0, 0, 0, 0. So a 31 is 1 less. So it's basically everything is a 1 over here. So it's 5 ones. So it's going to be 3 zeros and 5 ones. That's going to be my 31. And then the next one was, let's see, from 32 we went to 64, so it's going to be a 63. And again, this is 64, so it's going to be 0, 0, and the rest all ones. So 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6. All right, then the next one is a 96, so I need a 95. The next one I need is a 96, so I need a 95. So I went online and pulled up a binary to decimal converter calculator, and I put in the number 95, and I press the button, and I get 1, 0, and 1, 2, 3, 4, 5 ones. So for that, I get 1, 0, 1, 2, 3, 4, 5 ones. So I need 8 altogether. 1, 2, 3, 4, 5, 6, 7, 8. So I have 0, 1. So I keep the 1. I change the second place to a 0, and I add all ones. And that gives me my 95. And again, I want to keep going until I get to the last one. So the second part of this question says, what does the host portion look like of these addresses? Well, remember the host portion was the last 5 bits. So notice 1, 2, 3, 4, 5. They're all ones. All ones for the host portion of this one.